We position the coil exactly with respect to the MRI scan we made prior to the experiment, so that we know exactly where the coil is, or rather where the TMS pulses will end up in the brain. Of course, our target is primary visual cortex, which is highlighted in red now. So the information enters his eyes here, of course, but then it's sent to the back of his head, to the visual cortex. And from there, it's distributed over the rest of his brain, all the way to the front, for example. And here you have motor cortex, here you have prefrontal cortex. All these areas are activated within 1 or 2/10 of a second. So there's a very rapid transfer of visual information going from the back of the head to the front of the head. Now, when you have that, even though the whole brain is activated, you still do not have a conscious sensation of whatever evoked this activity. It's only when signals are sent back from the front of the head to the back, when you have so-called recurrent interactions, that a conscious sensation starts to emerge. And that's what we are trying to disrupt by means of these TMS pulses. The clicking you hear now are the pulses of the TMS coil. And the idea is to deliver these pulses, these clicks, exactly at the moment when these recurrent signals reach back to the primary visual cortex. And indeed, what you observe in that case is that when the activity in primary visual cortex is disrupted at this moment, the subject will no longer be able to see what is going on the screen. He will no longer be able to see the squares that you can see appearing every now and then in the center of the screen. No recurrency is no consciousness. Regardless where the activity sits, if it's not recurrent, you do not have a conscious sensation. You can have, for example, visual consciousness in the right hemisphere. Of course, if it stays there, if it's only if it's only in the right hemisphere and is not transferred to the left hemisphere, you will not be able to speak about it. You will not be able to say, well, yes, I saw this or that visual stimulus, but nevertheless you have a conscious sensation. The only thing is you don't know it. The thing I would like to know is exactly what consciousness is. And until now we are used to define consciousness in psychological or philosophical terms. So, for example, we say, I am conscious of something when I say that I'm conscious of something. However, it is becoming clear now that this is actually a very bad definition of consciousness, mainly because we don't know what we are conscious of. So the thing I would like to do is replace that psychological definition, if you like, with a neural definition. So I try to identify a particular neural process in the brain and then say, this is consciousness. And then when I see that neural process happening in the brain, I can tell you, you are conscious of something, even if you would disagree with me. You cannot define consciousness in strictly behavioral terms or psychological terms, because what you would have to do then is make some sort of decision as to what kind of behavior counts as evidence for having a conscious sensation or not. For example, if someone tells me that he has seen something, of course I would believe him. But what, for example, when he would draw something, but at the same time not tell me that he has seen what he's drawing? And this happens, for example, in split brain patients. These patients will tell you that they didn't see what is going on in the left side of the visual field. However, they will be able to draw it with their left hand. So then you have to make a decision. What is counting as evidence for having a conscious sensation? What this person tells you, or what this person is drawing? And so you end up in endless, more or less philosophical discussions as to what kind of behavior would count as evidence for conscious sensations. And it's becoming very clear now that we are not getting any grip on what consciousness actually is in this way. Now, if you would have a neural definition of consciousness, of course a very big advantage would be that, for example, you can assess whether there is consciousness in, well, problematic cases, such as in patients in vegetative state or coma. You can identify whether the neural process that I identified as the neural basis of consciousness is present in those patients, and then if it is, you would have to conclude that this patient has conscious sensations, even though the patient is not telling you that he has conscious sensations. But of course he's not telling you because, well, for example, there are problems with his motor cortex, etc. And so this is, I think, a very good example of someone having conscious sensations without you knowing it, but maybe also without himself knowing it. But nevertheless, I would be reluctant to pull the plug on such a patient.